So we're going to run a second experiment. This time we've got fish in a lake. So Ministry of Natural Resources wants to know the ratio of bass to carp to catfish in a given lake, and so they ask registered anglers to keep track of their fish. Okay, so we're going to use colored tiles to simulate this particular method for figuring out fish population. So in this case, we've put 15 colored tiles into a bag or into a container of some kind, and we're going to say that bass are represented by green. So there's 7 green tiles in there. Okay. And we're going to say that carp are represented by blue, and finally catfish are represented by red. Okay. Now, that means that the ratio of these things, out of 15, we've got 7 bass. So we have 7 bass to 5 carp to 3 catfish. Okay, so that's our ratio. So if we've got the opportunity to run this experiment 30 different times, so we're going to pull a cube or a tile out of the bag or container 30 times, what would we expect to see? Well, I would expect, if I pull this out 30 times, I would actually expect to get 14 bass, because I've got 15 cubes in total, and I'm pulling them out 30 times. That means double each one of these options here. So 7 times 2 is 14. 5 times 2 is, I would expect 10 carp. And 3 times 2, I would expect to get 6 catfish. Okay, so what we're going to do is you're going to run this experiment on your own. Okay, and so you're going to record your results in a tally chart just like we had done before. Okay. So I've had a chance to run this particular experiment, and so my results are listed right there. So my results ended up that I had a frequency of getting 15 bass, I got 12 carp, and I ended up getting 3 catfish. So that just happens to be my results. Now your results are probably going to be different. So I want to figure out, well, what is that as a fraction and ultimately as a percent? So if I ran this experiment 30 times, and again, I can total up my frequency to get my total. Okay, so I ran this experiment 30 times. So 15 out of the 30 times, I ended up getting bass. So 15 over 30 in lowest terms is actually 1 over 2, because I can divide both of those numbers evenly by 15. Okay. Carp, I got carp 12 out of 30 times. I can divide both of those numbers evenly by 2, so that would give me 6 over 15, and I can divide both of those numbers evenly by 3, and that is going to leave me with 2 over 5. Okay, and then finally, I got 3 catfish, so 3 out of 30 events happens to be my catfish pulls, so I can divide both of those numbers by 3, and that leaves me with 1 out of 10. Okay, so if I want, I can also convert them into decimals and into percentages. Okay, so as a decimal, 1/2 is 0.5. 2 over 5 as a decimal is 0.4. Okay, 0.4. And 1 over 10 as a decimal is 0.1. Okay, and I can also convert them into percentages. So 0.5 as a percentage is 50%, 0.4 as a percentage is 40%, 0.1 as a percentage is 10%. Okay, so you may be asked, for example, to write something as a fraction lowest term in a decimal and as a percentage or some variation thereof. Okay, so what we want to do is we want to actually record, we want to write down our experimental results as a ratio between bass, carp, and catfish. So I know that in terms of the number of bass, and again, bass is represented by the green, I had 15 results that were bass. I know that my carp, which is blue, I had 12 that were carp. And finally, my red results are catfish, and I only had 3 results. Okay, so 15 to 12 to 3. Now you can convert that again, all 15, 12, and 3. You can all divide all 3 of those numbers into or by 3, and so that would end up being 5 to 4 to 1. Okay, so if you divide 15, 12, and 3, if you divide each and every one of those numbers by 3, you end up with this particular complete ratio, 5 to 4 to 1. Okay. So how does that ratio compare to the ratio of colors of cubes in the bag? Well, cubes in the bag, as we talked about earlier, we had 7 to 5 to 3. Okay. So our ratios are actually different in the experiment than they are in real life. Okay. So we could take a look here. So does the simulation give us a reasonable estimate of the ratio of colors in the bag versus fish? Okay, and so that's one that we can discuss together as a class.